Hello friends, and welcome to another lecture in which we are going to discuss about all the distinction tests, basically the important ones which are going to come in your board exams. Okay, so basically I'm asking, right, this is a phenol, say, and you are given with another organic compound, say uh, carboxylic acid, like here benzoic acid is given. Okay, this is a phenol and this is a benzoic acid, right? So you have to say you have to basically distinguish which is phenol and which is benzoic acid, because uh, in a normal environment you cannot say that the structure of phenol is this, the number of carbon, you cannot say that. You have to give a physical change, right? When I say distinction test, they always aim at physical change. Now what is physical change? Any physical change, like change in color, okay, change in color, say, or change in smell, or temperature of the solution, okay, or sometimes precipitation, okay. So these things, right, which you can either see or you can feel, right? So these are basically physical changes. So here we are always dealing with physical changes when we talk about distinction test, right? Now we are moving on to a PowerPoint, okay, where we are starting with Bayer's test, right? Now what is Bayer's test? Clearly, if you see the reaction here in Bayer's test, I am reacting this unsaturated ethene, right? Ethylene is common name. Unsaturated ethene with bromine water. This is aqueous, which is brownish red, or the color is something like this, okay, if you see here. So this brownish red bromine can react with ethylene, and two Br atoms can attach to the two adjacent carbon atoms, as in here, and it will get converted into dibromoethane, basically 1,2-dibromoethane here, and this is colorless. That is the different thing. But this bromine water, which was giving the brownish red color to the solution, this will be partially extinguished in formation of dibromoethane from ethene, so the solution will turn colorless. So basically Bayer's test aims at a change in color, okay, change in color. So this is the physical change you are getting here, right? In the other hand, if you are taking any saturated uh, compound and you are reacting with Br2, and you will basically get no result from it, because this Br2 cannot react with this thing, right? Okay, let's move to the next. This is the important one. This is iodoform test. Iodoform test, basically how it happens. See, for example, I'm taking CH3 and here acetone I'm taking, right? This is an acetone example, okay. So see what will happen when we are taking I2 with NaOH. It will react to give something called NaOI, okay. What is NaOI? This is called sodium hypoiodide, right? So what will happen? See, this I2 basically they will break the bonds here. One I will come to here, another I here, one I will come to here, like this the bonds will break. And okay, what will happen, this thing will form 3Hi and something like this. Okay, and now what will happen, the NaOH present here will come to here, this is H, here this side ONA, and now we will get CHI3, which is a precipitate, and CH3COONA, right? If you simply replace R with CH3, you will get such thing. Okay, now what will happen, this CHI3 is a yellow precipitate called iodoform, like CHCl3 was called chloroform. Similarly, CHI3 is called iodoform, and this is a result I have collected from the web as an example of iodoform reaction. So this is the clear solution in which we are putting iodine, and then this type of reaction takes place, and finally you get this uh, iodoform, right? This iodoform yellow color, right? Okay, now another thing, so how would you know basically that if this thing will undergo that iodoform test or will not undergo iodoform test? So let me explain it in this board. uh, Basically you have to always notice that okay, right, into shape should be off. Okay, basically you have to always take in view about this group, right? This particular CH3CO group. Okay, if this particular group is present in any compound, say CH3CO CH3, which is acetone we discussed, or say CH3 C double bond O H, which is an aldehyde, basically here ethanol. Okay, ethanol, or CH3 C double bond OH, anything. If this CH3CO group is present, in other words COCH3 is present, okay, then we can say that the iodoform test will take place, right? Okay, now another interesting fact, sometimes you get the question and many students get confused, so I would like to clear it here. If there is given that distinguish between ethanol and methanol, right? So here you see that you don't have the CH3CO group anywhere attached. So now you will think that how this thing will be taking place. Okay, let me now clarify you that this is ethanol, this is methanol, and basically if you want to distinguish between two things, here also we can do iodoform test. How? Basically we are doing a partial oxidation or mild oxidation. For mild oxidation you can use PCC. Okay, mild oxidation, and this thing will get converted into CH3CHO, which is an aldehyde again, and this thing will convert it into HCHO, which is again an aldehyde. This is formaldehyde, formaldehyde or methanol, and this is acetaldehyde or ethanol, right? And if you draw the structures of these two aldehydes, you see a CH3CO group is attached to this particular or this group is called acetyl group, right? This group is attached to hydrogen. So here, if I identify this group, means this will do a positive iodoform test, whereas here we don't see such thing. So here iodoform test will not take place. Here we will get CHI3, which is iodoform, right? Okay. Now let us move to our next test, that is FeCl3 test, right? So what is FeCl3 test? So FeCl3 test, you get a positive result when you use phenol, right? So this is the reaction. You basically don't have to remember the reaction. It's not that important, but you just have to remember that phenol, when it reacts with FeCl3, it gives a violet complex. Okay, it gives a violet complex, right? And this, of course, you have to remember. And this is what the reaction is. This is a negative result for FeCl3 test, and this is a positive result for FeCl3 test, right? FeCl3 actually is brownish color. Okay, and when you dip in water, it yellowish brown like thing, right? So this is a negative test, this is a positive test. And what will happen if you dip benzoic acid with FeCl3 neutral? What will happen is this will give a buff colored solution. So you don't have to remember this thing. Basically, you have to remember that this phenol, when react with FeCl3, gives a violet complex. So when you will be given to distinguish between phenol versus anything, you can just use FeCl3. This will give positive test to make violet complex, and this will don't make violet complex, right? Whatever it will make, that doesn't make sense here, right? So next question, this is important one, actually, Lucas test. If you remember, then Lucas test is done in an environment containing ZnCl2HCl, which is also called as Lucas reagent. Sometimes children write that it is taken place in zinc amalgam HCl medium, which is wrong. Actually, this is done for reduction, Clemmensen reduction. We will do a video upon this name reaction someday. Clemmensen reduction, right? So don't get confused. So Lucas reagent ZnCl2HCl, what happens that this OH group is replaced by a Cl group, and H2 is liberated. And the basic thing is here, if you react a tertiary alcohol, for example tert butyl alcohol, in earlier video I have made you understand what is tert butyl structure. This is tert butyl alcohol, and when I add ZnCl2HCl or simply Lucas reagent, what I get is, this is the condensed form of writing this simple structure, tert structure. OH group is replaced by Cl, right? And H2 is liberated. So this reaction takes place immediately, right? This reaction takes place immediately. But wait, okay. But if I consider of a secondary alcohol, the same reaction will take place after 5 minutes. Okay, the same reaction will take place after 5 minutes. But if I consider a primary alcohol, then the reaction will not take place at all in ZnCl2 HCl environment. Okay, it will take place if we raise the temperature. Raise the temperature. Okay, basically we will heat it. And why this thing happen? Clearly, if you know SN1 mechanism, you can easily find out that the formation of tertiary carbocation is more stable when we will be doing SN1 SN2. I will make you understand there. Okay, why formation of tertiary carbocation is more stable, right? So this is as this is a revision class, so I will proceeding with what is on the PPT, right? Okay, next I'm going with NaOH test. NaOH test is basically due to identify the COO minus group or carboxylate group. Here if you observe, I have given a diagram of a test tube. Okay, first ignore that. So if I take a benzoic acid and make it react with sodium bicarbonate, right, NHCO3, so what will happen? That sodium benzoate will be formed. This thing you actually learnt in 10th class, right? So heating in the presence of sodium bicarbonate, so sodium benzoate will be formed and water will be liberated, which doesn't make any sense, but CO2 will be liberated, right? And uh, you earlier know that CO2 turns lime water milky. Okay, what is lime water? CaOH, and when we add CO2 to it, it forms CaCO3. Okay, it forms CaCO3, and of course H2 is liberated. The H2, let me write. Okay, so this CaCO3 is calcium carbonate, which is present in chalk and all, so it gives a milky appearance with water. uh, that's why I have given this diagram where sodium bicarbonate is evolved and dilute acetic acid is taken, acetic acid CH3COOH. It contains the COO minus group, so this thing will react and carbon dioxide gas will be evolved, and here a cork is given and this gas is passed to a delivery tube into a test tube where CaOH solution is there, and it will turn the lime water milky. Again, there is a color or precipitation change, so you can, not precipitation, actually a color change, okay, from colorless to milky solution, so you can easily say that this is a physical change. Okay, so what happened in Lucas test? Lucas test also a color change, right? And phenols, this also color. Iodoform, this is precipitate, right? And Bayer's I already told this color. Okay, let it. Now I'm going to tolerance test. Okay, tolerance test, right? Okay, before going to tolerance test, I'm telling you that uh, this Lucas test between primary, secondary, and tertiary alcohol, right? But what if you are given with differentiate between an aromatic alcohol and aliphatic alcohol? What will you do? Again, it's simple. See, you can simply do the FeCl3 test, right? As I told you, FeCl3 neutral solution test. Anything alcohol versus anything, you can do the FeCl3 test, and here you will get a pilot complex. Here you get nothing like that, right? Okay, now tolerance test. So what is tolerance test? To be precise, tolerance test is done in the presence of the AgNH3. This is a complex, right? AgNH3 whole 2 plus. This is tolerance reagent. This is tolerance reagent. When it is allowed to react with benzaldehyde, it actually oxidizes that CHO group to COO minus, and it forms many byproducts like ammonia, water, and also silver. This silver actually gives the appearance of silver mirror. This particular word is used. See, this is the colorless solution, and when you add uh, AgNH3 whole twice to it, so silver mirror will be formed. This is after placing it in a cool bath. Okay, after placing it in a cool bath, so the silver mirror will be formed, and again this is a precipitate and even a color change, so you can easily identify that okay, this is an aldehyde and that is not aldehyde. Okay, and this is possible for both aliphatic and aromatic amines, right? But the next what we are going to discuss, Fehling test, is not possible for aromatic amines. This is Fehling test. Fehling test actually, there is a Fehling solution which contains Fehling A and Fehling B. Fehling A is nothing but CuSO4 dot 5H2O, okay, which is blue vitriol or copper sulfate, and Fehling B is Rochelis salt. Pardon with the spelling if it is wrong. Rochelis salt, which is sodium potassium tartrate, sodium potassium tartrate, right? Okay, let me go to the whiteboard to make you understand. So no one asked the structure, but just to know, I'm telling you, this is the structure of tartaric acid. Tartaric acid, OH, of course. You replace one H here, add sodium here, you replace H here, add potassium here. You can do it either side. So this is sodium, potassium, and of course the tartarate ion. So this becomes sodium potassium tartarate, right? Sodium potassium tartarate. This is Fehling B. Okay, so Fehling B and Fehling A, when added, they give Fehling solution. Now what happens in Fehling solution, if you want to see what happens in Fehling solution, is, see, this Fehling solution when added to a aldehyde, note, aromatic amine doesn't respond to this Fehling test, right? So you take an aldehyde, essentially aliphatic aldehyde, and you react with Fehling solution, you will get this CHO group oxidized into COO minus, and Cu2O will be formed, which is a red precipitate, right? Which is a red precipitate. Okay, H2O will of course be liberated, and if you see this blue color solution, by time it converts into red color solution. This is brick red type thing. Okay, so this is a Fehling test. So what do you know in Fehling test and Tollens test? Tollens test we can use to distinguish between aldehyde and rest. Fehling can be used also to do the same, aldehyde and rest, plus an additional use is it can make you distinguish between aliphatic and aromatic aldehydes. Okay, so don't get confused while answering the questions. Okay, so moving forward, we have two more tests left, that is carbonylamine test and Hinge reagent test. Okay, so what is Carbonylamine test. Carbonylamine test basically is used to distinguish between primary amine and rest of amines, right? Or any rest thing like primary amine and phenol or anything. So this primary amine, when it will react in a chloroform medium, okay, in the presence of an alkali, here is KOH, and we raise the temperature by heating it, we will get this isonitrile thing, plus we will get byproducts like 3KCl and 3H2O. Okay, another thing which is important, that this isonitrile gives an unpleasant smell. Okay, so first of all, except color or precipitate, you got to see something which is related with smell, right? So this gives you an unpleasant smell. Which compound? This primary amine, when it get converts into that isonitrile in the presence of chloroform and an alkali, basically KOH or NaOH. Okay, so this gives you an unpleasant smell, and you can say that okay, this was primary amine. And if it doesn't, it gives you an unpleasant smell, you can say that okay, it was not a primary amine, right? This thing get done also in presence of a aliphatic amine, not necessarily aromatic amine. Okay, but the question arises here, what if you are given with something like this is a primary amine, this is the secondary amine, and you have to distinguish between them. So you can easily say that this thing will undergo carbonylamine test and this will not undergo carbonylamine test. So clearly you will get to know which is the primary amine. But if you are asked to distinguish between secondary amine and tertiary amine, then this carbonylamine test will not work. Okay, so there we do another test, which is Hinge test, and in that we use Hinge reagent, which is benzene sulfonyl chloride. Benzene sulfonyl chloride, this is the benzene, this is the sulfonyl group, this is Cl. Okay, so this is the benzene sulfonyl chloride. When you want to react it with primary, secondary and tertiary amine, you just see what happens. Okay, so if I'm taking a primary amine, okay, sorry, if you are taking a primary amine and you want to react it with benzene sulfonyl chloride, then basically this chlorine will mix with one of the hydrogen here and will be liberated in the form of HCl, and this C6H5SO2Cl was here. C6H5 stands for benzene, will get joined to NH. So basically from RNH to one hydrogen, and from benzene sulfonyl chloride one chlorine atom, they get liberated in the form of HCl, and this product will be formed, right? Again, if we are reacting R2NH, this is a secondary amine. If we want to react with Hinge reagent, what will happen? Again the same sort of thing will happen, but here as we were having two hydrogen, we are left with one hydrogen. Here we have one hydrogen, so we'll be left with no hydrogens. Okay, and again if we want to react with a tertiary amine in the presence of Hinge reagent, then we don't have any hydrogen with the nitrogen atom, right? So this thing will not, reaction will not take place. Okay, Okay, let me rub this thing and I'll make you understand again. Okay, so what we got when we reacted a primary amine with Hinsberg reagent, we got C6H5SO2 H and R. Okay. Okay, let me do it like this. And when we do it the secondary amine with the same Hinsberg reagent, we got C6H5SO2 and R. And of course tertiary amine, no reaction. Tertiary amine, we get no reaction because lack of hydrogen and nitrogen atom. Okay, so by this you can simply say that this is a secondary amine, this is a tertiary amine, but again you see that the reaction is taking place with primary amine and secondary amine. Now how can you distinguish it with Hinsberg reagent itself? So now what we'll do, we will mix this product form in an alkali medium. Okay, in an alkali medium. What is alkali? Alkali strong base. Okay, NaOH or KOH. And as there is a presence of hydrogen here, water can be liberated and product can be formed, or simply I can say that this is soluble in alkali. Okay, soluble in alkali. But here as no hydrogen is present, no reaction will take place, so it is insoluble in alkali. Okay, insoluble in alkali. So this is what flowchart you got. Hinsberg reagent, complex formation takes place, alkali, soluble. Secondary amine, Hinsberg reagent, complex formation takes place, alkali, insoluble. Tertiary amine, Hinsberg reagent, no reaction takes place. So this is how basically you distinguish amines, primary, secondary or tertiary, by Hinsberg reagent. Okay, done. Okay, now let me go to my whiteboard and ask you, give you some important descriptions about how questions you may get. Okay, okay. So question can come like this is aromatic amine, this is aliphatic amine. Okay, now how will you distinguish between them? Bit long process, but you can do. So basically we have to reach to a point where we know what we have read. Okay, what prerequisites we have, according to that we can do. So here there is a process called diazotization process, or formation of diazonium salt, that takes place in the presence of NaNO2 and HCl. NaNO2 and HCl will give you HNO2. Okay, and NaCl will be liberated. This is nitrous acid. Okay, so an aliphatic amine, or simply aniline, in presence of NaNO2HCl or nitrous acid HNO2 will get converted into N2Cl. Negative, this is positive. Okay, this N2Cl, this is called diazonium salt. Why diazonium? 2 nitrogen, so nitrogen is called azo, so diazo and diazonium salt. But when you react an aliphatic amine with NaNO2 HCl, you get alcohol as main product. Okay, here diazonium salt doesn't take place, because if such thing will formed, then this is unstable and it will readily get converted into alcohol, nitrogen and HCl. Okay, so you will get alcohol as the major product. Now, can you distinguish between this diazonium salt and alcohol? No, you don't know, right? So again, you have to carry out a reaction. What is the reaction? You can add boil water here also, and you can add boil water here also. Basically here no reaction will take place. Okay, only dilution of alcohol will take place. But here what will happen is the formation of phenol, right? So this phenol so formed, now you can always add FeCl3 neutral and you will get a violet complex. And here of course, as this is a aliphatic alcohol, no such reaction will take place, right? This is how you do. So according to what you saw here, conversions and distinguish tests are somewhat interlinked. You have to know both, okay, right? Sometimes you don't know how to distinguish between two compounds, but you can convert them to some other compounds and you can then distinguish them, like what we did here. We converted aniline into phenol and this aliphatic amine into an aliphatic alcohol, and then we know the test, right? So thank you, and we will do a questionnaire session where we will do several questions relating to this distinguished test and all. And till then, like this video, share it to your friends, as they might find it helpful for their upcoming exams, and do subscribe to CBSE Point. Thank you.